very small agenda for the first session. Starts with a small intro. A small intro on disruptive technology. Then directly we are entering into the very 1 or 2 slides for augmented reality. Then theme of this 1.5 hour session for object recognition and tracking in augmented reality using MATLAB. So one of the excellent technology, which is named as haptic technology, which is plays a vital role in augmented reality domain. So a small demo on haptic technology. Then the excellent tool, which will be named as computer vision toolbox, which is available in MATLAB. So small demo on computer vision toolbox for object tracking. At last, some of the MATLAB experiments. So it's a small agenda for this 1.5 hour session. So before entering into session, just a small story and then entering into a session. Starts with a small story. So the story begins. So once upon a time, because normally storyteller starts a story like that. So I'm also starts on the same way. So once upon a time, there was a giant ship, a very large ship. The ship was failed. So the ship owners tried to solve the problem. So he called the expert one after another. Each and every expert came to the ship and inspect the engine from top to bottom. But none of them figured out what happened on the engine. None of them figured out what happened on the engine. So ship owner was so sad. He called the old man. He was a ship engineer when he was at young. The old man came to the ship with a large bag of tools. The old man came to the ship with a large bag of tools. He immediately starts his work. He inspects the engine from top to bottom. The 2 ship owners were watching them. So the old man took a small hammer, from his large bag of tool. With the help of that small hammer, he gently tapped on the engine. Immediately the engine was lurched into life. Everyone was very much happy. Few days later, the ship owners received a bill from the old man. The bill was, he hardly did anything. The bill was actually $10,000. So ship owners was shocked. So he write a letter to the old man. Dear sir, please send an itemized bill. Because just with the help of small hammer, he simply tapped on the engine, but asking for $10,000. So he write a letter to the old man. Dear sir, please send us an itemized bill. The old man replied and sent the itemized bill. The itemized bill, which comprising of only two items, using hammer for $2. Where to use hammer for $9,998? Dear friends, where to put your effort is very, very important. So the IFET College of Engineering, Viluppuram, they are organizing such an excellent FDP for augmented reality. So where to put your effort? So utilize that opportunity for the 14 days to learn about augmented reality and the research domain. So effort is important, but knowing where to put your effort is very, very important. So technology for everyone, even a bat can operate a mobile phone. So dear friends, you can learn this augmented reality technology with object recognition and tracking for your future research work. So starts with the small intro on what is disruptive innovation. So disruptive innovation, something that generates a very important change in the society or world. That will be called as disruptive technology. So in the year 1960, one of the excellent disruptive technology, which will be named as supercomputers. 1960s, the excellent technology which will be named as supercomputers. That will be called as disruptive technology in the year. In the year 1980s, a personal computers, which is a disruptive technology, which dominates the world. The personal computers, which will dominate the world. In the year 1990s, that is the rise of World Wide Web, the internet. So internet dominates the world in the year 1990. So 1990s, disruptive technology was internet. In the year 2007, iPhone, the launch of iPhone, which dominates the entire world. So disruptive technology in the year 2007 was iPhone technology. So have you ever heard about the word augmented reality? Yeah. So a technology that adds something augments, the technology that provides some additional information about the real domain. Augmented reality is a technology that augments some additional information about the real world. So that will be called as augmented reality. So it provides some additional information about the real world. That's augments. So for example, the picture may worth 1,000 words. So you can extract those 1,000 words from the picture. So here, the hotel. So the photo of US city. So which will extract the hotel photo. The height of hotel was 300 meter. The height of bar was 620 meter. The another location was 750 meter. So which will be provided as GeoWeb. So extract information from the real world, which will provide the entire information. That will be called as augments the information about the photo. Augments the information about the real society. That will be called as augmented reality. It's just a small intro on augmented reality. Do you think a technology of future? No. It's a technology in your hands. Everyone having a mobile phone. So even recent mobile phones, all the recent mobile phones, which comprising of augmented reality domain, which extract the information from the geo information from the society. So the future technology was Google Glass. The future technology, future disruptive technology, which will be called as Google Glass. It's a sixth sense technology, which will provide the entire information about the society. It provides entire information about this society. So that's called as disruptive technology of the future world, Google Glass. So the change, just with the help of a mobile phone, just take a photo of nearby location, that's a hotel or building or road or any images, something. You can just take a photo. Immediately your mobile, which will extract the entire information about the photo, where the hotel is, the location of the hotel, everything which will be extracted with the help of augmented reality. So augmented reality is an excellent domain which will provide the entire information about the society. So it's a dominating technology. So current 2020 disruptive technology, one of the disruptive technology which will be called as augmented reality. So the college chooses such an excellent technology, excellent topic for you. So what is augmented reality? What's augmented reality? So a picture may worth 1,000 words. Here there is a picture. So the picture, all of them well known about the picture. The picture was, that's a woodpecker. But just take a photo of that picture. Just take a photo of that picture. Immediately the augmented reality, which sends that, which will say it's a woodpecker. Which will say it's a woodpecker. Yeah, it's correct. So automatically which recognize the image. That will be called as object recognition. So you can take a photo of the picture, immediately which will recognize there is a tree, there is a plant, there is a woodpecker. So everything was analyzed. So that will be called as object recognition. So it's a first methodology in augmented reality. So second, which recognize the entire information, that is augmented glasses, which extract the entire information. That will be called as woodpecker. It's a name of the object. Where do they live? What do they eat? So entire information, the entire information about the woodpecker, which will be extracted from the society. So it's a recent disruptive technology because just take a photo which extract the entire information from the picture. So normally the olden days proverb, everyone says a picture may worth 1,000 words. So current theme was extract those 1,000 words from the picture. Extract those 1,000 words from the picture. It's just a small intro of augmented reality. Then we are entering into a demo. So it's give us better knowledge about reality. So augmented reality, which gives the better knowledge, which will give the better knowledge on education domain also. So the basic objective of this domain, just with the help of a GPS sensor camera, which extract the information, that will be called as POI, the point of interest. That will be called as data mining, key features. So which extract the features, the feature which will be transmitted to the server, that is cloud server or fog server or edge server, which will be processed and then verified with the entire information about the current object, extract those information from the database, and the related information was displayed. For example, if you take a photo of Eiffel Tower, the tower as well as the located information, everything was extracted as POI, that is point of interest. So key features are extracted. All those key features are transmitted to the cloud server. The cloud server processes entire information in a fraction of a second and then fetches the related information from a DB, and then the related information was displayed in a fraction of a second with your current device, that is mobile device. So that's the theme of geolocation AR. So Eiffel Tower. Just take a photo, immediately which will say it's a Eiffel Tower. It's located in the GPS location of 400.300, something like that. Then which will send several set of information, related information about Eiffel Tower. That's the advantage of AR. That's the excellent advantage of the domain which will be called as augmented reality. So currently the augmented reality, which also entering into agriculture. Just take a photo of plant, which will provide the entire information about the plant. So even currently all the new mobile devices, which also adapted with AR technology. The current mobile devices which are adapted with AR technology. So in education field, currently in a pandemic situation, the entire education field also changed into flipped classroom. So leave the classroom and learn from anywhere or everywhere. So the entire classroom structure was changed. That is flipped classroom, something called as changing the environment into different location. So the classroom is everywhere. Classroom is anywhere or everywhere. Anywhere or everywhere you can access the entire classroom information. So the entire society, the entire education technology was changed into flipped classroom mode, blended classroom mode. So now the education technology, which uses animation, simulation in augmented reality. Yeah, learning by experimenting, which will provide the entire 3D information about the plant. So it will provide the entire information in augmented reality in a 3D manner. In addition to that, for example, if you are learning about the picture of iris, so the human face as well as the iris picture was clearly explained via augmented reality. The software which will be called as RealTat. RealTat is an excellent software which will provide the more significant learning about any 3D object. So it's very much helpful for the current learning mechanism. So the education field, the current education field, something called as blended mode or online mode of education or flipped classroom methodology, which needs augmented reality for significant learning. So significant learning is very much important. For that, the RealTat, it's one of the excellent software which will provide the 3D environment. For example, in agricultural domain, so it's also 3D pictorial representation, which gives the entire information about the book or about the contents. So the superimposing information, it will provide the hardware. For example, if you are servicing the motherboard, in that situation, each and every IC, each and every sensor, because day by day, the size of IC, size of sensor was reduced a lot. So in that situation, you can extract the information from the board. It's very typical. But the current augmented reality domain, which improves training, which also provide accident prevention, the cost reduction. So currently every domain, each and every domain which changed into augmented reality with the help of one of the excellent software which will be called as MATLAB 2. So now I am entering into the topic of object recognition as well as object tracking. It's a small overview of augmented reality because the first session. So starts with a very small overview of augmented reality. So augmented reality, just take a photo which extract the information from the entire information about the photo. That will be called as a computer generated image on user view. The computer, for example, if you are walking on the street, immediately you can say the right side there is a medical shop, in the left side there is a restaurant, then there is a coffee shop is available, one of the guy is playing cricket, something like that. You can view the society or view the road and then say something about the road. Similar way, a computer or mobile camera can view the environment and extract the information and display in front of you. That's called as augmented reality. That's the excellence of augmented reality. So entering into the core of today's session, the core of today's session, which will be depends on object detection as well as object tracking. The theme of the first session was object detection and object tracking with the help of the excellent tool which will be called as MATLAB. So as a name itself, object detection, which detects a particular object in an image. So detection in the sense which detect a particular object in an image. For example, if you are having a photo, which will detect the ball, which will detect this is a bat, this is a stem, something like that. So which detect object in a particular image. As a name itself, object tracking, which will track the moving car. For example, if you are having a video, object detection in the sense if you are having a image, object tracking, the sequence of image. Normally sequence of image, which also called as video. So the entire video, if you track a moment of human, for example, a surveillance camera, if you track a human moment, otherwise, for example, a traffic camera, you can track the entire car, the moment of car. So the theme of object detection, to detect what are all the objects placed on the location. That's called as augmented reality. So you can detect all those objects, augmented reality, which recognize the object and then extract the information. So the detect object as well as track object. That's fine. Yeah. The traffic information, object tracking, a picture. So it will track. For example, there is a rose circle as well as violet circle, which will track the car, which will track the entire car, entire moment of car. Automatically, the traffic information system, which represent the clear car was count was 1, 6 cars are located behind that, something like that. So which will display the entire information. So the augmented reality, which also helps for traffic. In addition to that, which is helpful for video surveillance. So number of human beings moving on that environment, which also detected on the surveillance camera. So these are the CCTV camera. The motion was automatically extracted. In addition to that, which says several information, whether an abandoned object in a railway station continuously for 15 minutes without any human being, a suitcase was placed on that location. Immediately the surveillance camera, which automatically recognize there is an abandoned object placed on that location. That will be called as excellence of augmented reality. The CCTV camera with intelligence. The CCTV camera with auto learning mechanism. That's called as augmented reality. So anyway, there are some of the problems in that domain. So temporal variation, a dynamic environment change, the abrupt object and camera motion, multiple camera, because everyone using different camera, different resolution. That's the issue. The computational complexity, because for example, in your college, you are fixing something around 1000 CCTV camera. In that situation, how to process those 1000 CCTV camera information? That's very, very typical. Currently, there are numerous domains are available called as edge computing for processing at the CCTV camera itself. Second, which will be called as fog computing, process the data in a middleware. Third, which will be called as cloud computing. Anyway, the computational complexity is still there in augmented reality, because you can augment the real world. So which needs several processing power, which needs high processing power. So always computational expensive. These are some of the problems in that domain. So which needs high memory, which needs excellent frame rate. Normally the frame rate per second was 30. The excellent processor for processing those data. Now we are entering into the core methodology of augmented reality in object tracking as well as detection. So yes, you can prepare an image, you can take a photo of image or take a video of the environment. So automatically a computer camera which will read the data and recognize with the help of an algorithm which will recognize and then display what the object is. The object is woodpecker. That's a object is Eiffel Tower, something like that. Otherwise, which prepare the video, read the video or from camera, then track the entire information, entire object, that is either car or human being, track the entire information and display the tracking object. For example, a car was moving on the more speed, so that will be extracted. So it's a core methodology, core step-by-step procedure of object recognition as well as tracking. Just a basic information about recognition and tracking. So the first and foremost basic methodology that will be called as absolute difference between frames. A video which comprising of collection of frames, the difference between two frames. For example, the frame I of Ti as well as I of Tj. Just subtract. That is called as background subtraction. Just subtract two frames. See the picture. It's a picture 1. It's a image 1. It's a image 2. It's a image 1. It's a image 2. You can subtract image 2 from image 1. or image 1 from image 2. That's not a problem. So you can subtract one image from other, then immediately which recognize what are all the object present. What's the difference between these two images? That's one of the human being moment which will be represented, and one car which is moving at that location. So one of the easiest methodology which will be called absolute difference between frames. So object was easily detected. Object was easily detected. So frame 1 and frame 2, frame 1 and frame 10, the difference between frame 1 and frame 10, which represent the object in a clear way, So it will be called as frame differencing or background subtraction, or otherwise absolute difference, absolute key frame difference, because frame 1 and frame 10, that is key frames. So basic methodology which will be called as frame differencing as well as background subtraction, which plays a vital role for detecting objects. So now we are entering into one of the excellent toolbox available in MATLAB, that will be called as CV toolbox, computer vision toolbox. As a name itself, computer vision, it's a science and technology that machines see the valve. So just see the valve via camera and then detect the environment. So make a computer with sixth sense. Computer can analyze a picture and says what kind of scene is, where are the cars, how far is the building. So all those information which extracted via the camera. So the olden days vision technology, human can view the scene via human eye. The human eye take a photo of image, and then human brain can process those data and then represent the information about the picture. You can see the picture and then your brain can process and then it says what the picture is. You can see the picture via your eye and then you can process it via your brain and then you can say the perception about information about the picture. Similar way, the current trend was changed. A camera can see the valve. That's called a computer vision. A camera can see the valve, and then with the help of a computer, you can process the image. A camera can see the valve. With the help of your computer, you can process the image, and then the computer automatically says the information about the picture. So olden days, your human eye can see the picture, and your brain can process the data, and then you can say the information about the picture. The current environment was totally changed, a computer vision. A camera can see the environment and computer can process the image and then which returns a result, which returns the perception of the environment. That's called as augmented reality, which extract information via a camera, which will be achieved with the help of CV toolbox, which is one of the excellent toolbox which are available in MATLAB software. So with the help of CV toolbox, you can extract the entire information about the picture. So why computer vision? So normally image may worth as 1000 watts. Your theme was extract those 1000 watts from the image. So currently many biological systems rely on computer vision. The world is 3D, dynamic. So you need a CV toolbox for processing those data. You need a CV toolbox for processing those data. Currently the cameras as well as the processing computer cost was very cheap. So the computer vision was easily achieved. Many more. The example, finding a people in an image, give an image, it can find all those 6 images. The human being are represented in different locations, but all the 6 images which represent, yes, the instance comprising of human being, yes, which represent the human is placed on the photo. But here another 6 pictures which will be represented in a slide. So automatically the computer which recognize there is no human instance. There is no human instance placed on the page. So it auto recognize the image and then represent human present or not. So use the right tool for right job. Use the right tool for right job. For example, there is a huge tree, very huge tree, With the help of small saw, if you cut the tree, which will take 10 days, 20 days, or 40 days time for cutting the tree. So with the help of an excellent tool, which will be called as power cut saw, you will cut the tree in 1 hour. So the large tree, you are choosing a very small saw. With the help of that saw, you will cut the tree, which will take more time. But there is an excellent tool is available. That's called as power cut saw. With the help of the excellent tool, if you cut the tree, within 1 hour, it's possible. So similar way, the MATLAB is one of the excellent tool for cutting small piece of wood. But if you are having a larger tree, in that situation, power cut saw is needed. If you are processing a smaller data or smaller video, in that situation, MATLAB is enough. If you are processing smaller data or smaller video, in that situation, MATLAB is fine. If you are processing into larger video, in that situation, power cut saw is needed. If you are processing smaller data, saw is enough. If you are processing larger data, power cut saw is needed. Similar way, MATLAB and CV toolbox. Smaller video, MATLAB is fine. If you are processing larger video, or HD video for extracting information, in that situation, the excellent tool is needed. That tool called as CV toolbox. 1 second, please. So processing on smaller data, MATLAB, larger data for excellent handling, you will go for CV toolbox. So starts with a very small demo, just a 3 or 4 lines program. So just a first line of MATLAB code, video handler, that is called as VID, which is equal to video reader of, VID equal to video reader of, then name of the video, which extract the summary of multimedia reader, which extract the entire information about the video which comprising of 30 frames per second, then it's RGB image of 160 cross 120 pixels, which comprising of totally 241 total video frames are available. So just with the help of a single constructor, video reader of name of the video, which will extract the entire summary of the video. So again, read of VID. So you can pointing this video with the help of the pointer, that is handler, you can read the object and store in variable MOV. Just a function which will be called as imPlayOff, which is available in MATLAB. MOV, you can play that video. Video reader, which choose to read the video, pointing the video. Read off, which choose to read the video. imPlayOff, which choose to play the video. Just 3 lines for playing video, entering into a core. So VID equal to video reader of, cat video.avi. So VID which pointing cat video.avi, VID dot number of frames, which will return number of frames available in that video, because VID is a handler of the video. Number of frames is the attributes. So VID dot number of frames, which will return number of frames available in the video. VID dot height, which will return the height of the video. VID dot width, which will return the width of the video. So the entire information about the video, which will be displayed. So VID is a handler. Which choose to pointing video reader of cat video.avi. VID dot number of frames, which choose to extract number of frames in that video. VID dot height, which extract the height of the video. VID dot width, which extract the width of the video. So for example, just a small for loop for I equal to I something variable name. 1 to number of video frames, starts from first frame, ends with 241. Starts from first frame and ends with 241. 1 second. It reads a video from the starting frame 1 to number of frames. The last frame was 241. So it's read a video. So read off the video object, comma II. So first frame, second frame, third frame, which write the image. So entire video which comprising of 241 image. So the 241 image which will be written on image1.jpg, image2.jpg, image3.jpg, something like that. So automatically which will be right on that video. So video which will be extracted via this frame. It's a olden days technology. It's a olden days technology available in MATLAB. For example, currently I am reading a HT video. It's a olden days technology available in MATLAB. Currently I am reading a HT video. So video reader of my HT video was 1.avi. So immediately the olden days MATLAB, which will return a error message, not enough memory available. Because olden days, the virtual memory was not utilized. So the ability for handling a video, a small size of video was possible for handling via video reader class. So the current MATLAB software, which comprising of excellent toolbox, which will be named as CV toolbox. The current MATLAB software, which comprising of the excellent toolbox, which will be called as CV toolbox, computer vision toolbox. So which automatically handle a HD video, which automatically detect and extract the information from the object. Yes, we are entering into CV toolbox. So it's a computer vision toolbox. So each and every handler, the handler one, vision dot video file reader. Each and every constructor or function which handled via the object called as vision. So vision dot video file reader of the name of the video. Vision dot video file reader of name of the video. It will be handled by a handler for video frame. A handler for video frame. Then handler for player, vision dot video player of. So vision which handle efficiently in a video. So while there is no for loop is needed, just a while loop is enough. So while is done of HVFR. So automatically when the video frame ends, automatically the while loop which works, video frame equal to step of HVFR. Step of is a function which choose to handle, which choose to process every data. So it can process the data, step of HP comma video frame. HP is a handler for player. HP is a handler for player. So the frame, the first frame was played on that player, second frame played on that player, etc., continuously, which will be played till the end of video. So any high definition video which played via vision dot video reader of, vision dot video player of, then entering into object detection in 2 lines code. Please just vision dot image complementer, vision dot auto thresholder, vision dot image complementer or video complementer, no problem, vision dot auto thresholder. So image read of I am reading an image and store the image in an object called as I. So step of the auto thresholder comma image, result which will be stored in binary image, so BW. Step of image complementer comma threshold value, auto thresholder image, complementer image. Now, so everything which apply, just auto threshold automatically handle, then something called as image complementer which complement the image, and just I am using subplot function, it's not required now. So it will print the original image and then complemented image. It applicable for video itself, video also. So image complementer is a method in a fraction of second which complement the entire video. Auto thresholder which set the auto threshold, which identify the auto threshold for that picture. So vision is an excellent object for handling, for detecting object in an image. So it will efficiently process your data. Vision class which efficiently process your data in a faster and efficient way. Now histogram, all of them more familiar about histogram equalizer. So vision dot histogram equalizer. Vision dot histogram equalizer. Just I am reading a image X. Histogram equalizer which applied to X. Histogram equalizer which applied to X. See the picture? It automatically histogram equalizer. So it's a small exercise. Very soon we are entering into object detection in a 2-line step. Just for knowing functionalities, I'm explaining this function. So vision is object. Histogram equalizer is a class. HISTEQ is a handler for that object. Step off is a function. We are applying image as well as that histogram equalizer. The step off which process which applies the handler to that particular image or particular video. So that's the thing. So yes, fine. It's my first experiment of object detection. Foreground detector system object. Foreground detector system object which is available in computer vision toolbox, which automatically detect or track the foreground. A moment of car, a moment of human being, which automatically detected with the help of a foreground detector system object. With the help of a foreground detector system object. One vision dot video file reader. Vision dot video file reader of name of the video. Vision dot video file reader of name of the video. Normally, all are more familiar, all are from computer science background or electronics background, so that's not a problem. So video file reader, which comprising of the video file reader constructor, which comprising of collection of parameters, hundreds of parameters. So we are not using all those, we are not passing all those 100 parameters. So the mandatory parameter is video name. The additional parameter name, the parameter name along with its value. The parameter name along with its value, it will be specified like that. So because which comprising of 100 parameters, if parameters are not available for specifying empty or false, it's null. It's very typical. So it's the easiest methodology which followed in CV toolbox. So vision.video file reader of name of the video and the class name image color space. Image color space for applying the color space here, which will be intensity. The video output was unsigned integer 8 bits. So anything, you can give anything, that's not a problem. Currently I'm using this methodology. So HSRC, handler for my source video. Handler for my source video. Vision.video file reader. Input was my video file name. Image color space was intensity. Video output data was uint8. So now my handler HSRC, which pointing the name video traffic. Now I am creating the another handler HFG, handler for foreground. So vision.foreground detector. So the foreground was detected based on a short video. So number of training frames, a supervised learning mechanism, so which needs number of frames. So number of frames, a parameter was number of training frames. So here number of training frames which was given as 5. The initial variance was 30 cross 30. So standard deviation was 30, that's like that. So standard deviation was 30, that in the sense initial variance was 30 cross 30. So initially I am pointing a source video. Second, I am creating a foreground handler. The number of training frame was 5. The initial variance was 30 cross 30. Third, I am pointing another handler, that is blob, binary large object handler. Vision.blob analysis, not required these things. If needed, you can specify centroid, boundary box, minimum blob location, something like that, if needed. Otherwise, it's not required now. So I am creating 3 handler, first one for source, second one for foreground detection based on number of training frames and variants, third one for blob for boundary boxes. The last one, which will be called as sharpener. which will sharpen the image via vision.shape insert. Vision.shape insert. So which will insert the shape. There is a square border color of white. So which will place a white color border for car. Each and every car which will be bounded with a boundary box of white color boundary box. So now I am creating 4 handler. First one pointing video, second one pointing foreground object, third one pointing blob, the last one pointing shape. Now just 3 lines code, the video vision.video player. At last I am playing the video in detected object. I am playing the video with detected object. So HSNK equal to vision.video player. So I am creating 5 handlers. Is done of source. Not is done of source. So till the end of video, the video was played. Step number 1, source, reading source. Step number 2, applying foreground. Step number 3, applying blob. Step number 4, applying boundary boxes. So step number 1, reading a source video. Step number 2, you can apply foreground object. Step number 3, you are applying blob, binary large objects for boundary boxes. Step number 5, for inserting boundary boxes, drawing boundary boxes in the video or frames. Now step number 5, for play the final result in a vision.video player. So now the video was played. Everything was completed with the help of 10 lines of code. 10 lines of code, you can detect the foreground in a traffic video. Please see the result, and then again I am explaining the program. So please see the picture. The entire video, the car was tracked in boundary box. The entire video, the car was tracked with the help of boundary boxes, with the help of white boundary boxes. So again, I'm repeating the same for 2 minutes, and then I'm entering into second demo. So HSRC, it's a handler for source video. HFG, it's a foreground detector. HBlob, it's used to method of finding the binary large object. Then HSI is a shape inserter for border color. HSNK is a vision.video player for playing the final result video. While not is done of HSRC, so till the end of video which played the video, frame equal to SRC, step is used for processing. So initially the video, first frame was read and stored in frame. FG mask, the frame was applied, that is foreground mask was applied with the help of image. At last, the entire inserted video was played in vision.video player. So the video was played, and which is played with the help of the white boundary, played in addition to that, which adding a white boundary boxes. So the result was like that. Please count that. 1, 2, 3, 4, 5. The 5 lines for handler. These lines always common for all those video, just changing the handler name only. So 5 lines for handler creation plus another 5 lines for handling a video, which is always common. Only 5 lines plus 5 lines. So just 10 lines of code which track an entire video in an efficient and fast way. Foreground object detector, you are handling 5 objects and then you are handling the video. Just a small change. You are writing a video. There is a function which will be called as vision.video file writer. Same thing. There is a constructor which is named as vision.video file reader. Each and everything which is available under vision objects. So you can apply step of HVFW and video frame. You can write the video. So just 1 or 2 steps, automatically the CV toolbox which handle the video in an excellent way, So for next one, everything was same, just one and only change, the cascade object detector off. We choose to detect a face. Cascade object detector off, we choose to detect a face. So similar way, vision dot video file reader of, sorry, vision dot video file reader of, which choose to read a video. Step off, so read the video. Face detector. Face detector is a handler for vision dot cascade object detector of. So which automatically, with the help of this constructor, which automatically detect a human face. Just a 2 lines of code which applies augmented reality, which will generate, which extract the information, which extract the face, nose, eye, left eye, right eye, as well as the upper body and lower body, which detects everything in a single line of object. That's the excellency of CV toolbox. So video frame of step off face detector, comma video frame. So which will detect a face. If needed, you can insert a boundary box, that is shape inserter, and show the image. Yeah, see the picture. Which detect the face. Cascade object detector of. Cascade object detector of. Then inside this square, inside this parenthesis, I am specifying the inside double quote, single quotes, I am specifying nose. Immediately, the function which automatically detect nose. If you are specifying left eye, which automatically detect left eye. If you are specifying inside the parenthesis, you can specify left eye which detect left eye, right eye which detect right eye, upper body which will detect upper body, lower body which will detect lower body, the mouth which will detect mouth, nose which will detect nose, left eye which will detect left eye. So vision dot cascade object detector of is a method which choose to detect face. Inside single quotes, if you specify nose, which will detect nose, which will detect or track nose. If you specify mouth, which will detect and track mouth. Specify left eye, which will detect and track upper body. If you specify lower body, face, entire nose, as well as mouth, left eye, up object detector of, which will detect everything. Once object detector of, inside single quotes, you are not specifying any object which automatically detect a face. If you specify nose, mouth, left eye, which will detect nose, left eye, mouth, right eye, lower body, upper body in an excellent way. So it's the excellency of vision dot cascade object detector. So I'm entering into why the cloud computing. So once upon a time, there were 6 blind men. So even though they're willing to first blind man said, it's like a wall, because the man touching the part of the elephant. So it said it's like a wall. You're touching the part of the elephant. The second one said it's like a spear. Sorry. Second one said it's like a spear, because he touching the tusk of the elephant. He touching the tusk of the elephant. He said it's like a spear. The third one touching the tail of the elephant and said it's like a rope. The fourth blind man touching the leg of the elephant and said it's like a tree. The fifth blind man touching the ear of the elephant and said it's like a fan. The sixth one touching the trunk of the elephant and said it's like a snake. The 6 blind men are touching different parts of the elephant and argued with each other. One of them said it's like a fan, it's like a spear, it's like a wall, it's like a rope, it's like a tree, it's like a snake. So 6 blind men are touch and feel. So they argued with each other. Actually, which one is correct? Which one is applicable for augmented reality? Actually, augmented reality domain, which needs a mobile for processing data, that is mobile and cloud computing for faster processing data. So it's needed. Fog and edge computing, it extract the information and middleware processing is needed. It's also applicable for IoT, Internet of Things and Internet of Everything, for extract information via augmented reality, which also provide information from real world extraction, which helps for haptic technology, the machine learning and deep learning, which plays a vital role for augmented reality. So all the 6 technologies which is combined for next generation technology. So one of them said it's like a snake. Another one said it's like a spear, fan, wall, rope, and tree. All the 6 things are combined together for forming an elephant. All the 6 concepts: mobile, cloud, fog, edge, IoT, IoE, reality, machine learning, deep learning, and all the core technology which provide a background support of the augmented reality which dominates our. So all those technologies are needed for dominates the society, because augmented reality is excellent domain, but which needs a faster processing power, which needs the data from excellent IoE environment, which needs a middleware processing via fog and edge computing. So all these technology which support augmented reality to dominate survival. So it's one of the example. So a technology, cloud computing is a technology for provide anything or everything as a service. Augmented reality is one of the service which provided via AWS, something called as Sumerian. Amazon Sumerian is an excellent technology which provide AWS service. A similar way for face detection and face tracking via cascade object detection. So the edge detection which applied via the constructor called as edge detector. So vision dot edge detector is a constructor which used to detect the edge in a proper way, which used to detect the edge in a proper way. So augmented reality. So which extract, one second. So similar way, the edge detector which detect the edges, the handler was vision.video file reader, which read the video, vision.contrast adjuster, which adjust if needed, you can apply median filter. So vision object which comprising of collection of classes and collection of functions. Every which provide the entire information to the society. In the FL. So augmented reality, just 25% virtual, 75% real. The real environment, you can augment the information about the environment, but virtual reality, 75% virtual, 25% only real. So it's a basic difference. So AWS, one of the excellent cloud service provider, they are offering Amazon Sumerian. Amazon Sumerian is an excellent tool for providing augmented reality as well as virtual reality applications. So it provides an excellent cloud environment which also applied with CNN, convolution neural networks, along with deep learning. So it can process the data in a very fast manner. The AWS which offers 90 days free trial also. If possible, you can try on that environment also. MATLAB is also excellent tool, but which needs more processing power. If you are having excellent environment, excellent machine capability, then only it's possible for processing larger data. But AWS which provide excellent cloud environment for processing a larger data via Amazon Sumerian. So at last, my last program for object detection, which is called as abundant object detection. Abundant object detection. So based on my algorithm. So if you define the variables via my algorithm, that is MATLAB algorithm, that is ROI, maximum number of objects, something, you can define your own values. So similar way, vision.video file reader, you can read the video. Output type, just a single. Color space converter, if needed, you can convert RGB to YCBCR. Auto thresholder for threshold set to 1.3. If needed, morphological operation, that's not needed now. Blob analysis, so whatever handler needed, you can specify it here. Whatever handler needed, you can specify it here. So in addition to that, there are numerous handlers for a project. So all those handler was properly handled based on your required attributes. Then at last the video was played via the ROI index. It will apply the centroid and boundary boxes. And for example, there is a 30 or 100 frames. Continuously a suitcase is there. Without any human being, it just placed on the location in a railway station. The CCTV camera which automatically recognize the object and send the alert to the environment or alert to the people. That's called as abundant object detection via computer vision toolbox, which is available in MATLAB. It's object detection, tracking, recognition in augmented reality using MATLAB. It's one of the excellent application. The entire code was available in CV toolbox. In addition to that, at last I'm providing my website also, the entire presentation as well as the program, MATLAB program, which available in my website too. You can view that and run on your MATLAB. It's a small programming environment. So MATLAB is an excellent tool for processing all those things, but which needs more processing power. For reducing the processing power, we are entering into CV toolbox, computer vision toolbox, which available in MATLAB too. So now in that augmented reality, which helps for business intelligence, because in that augmented reality, which also process data in an efficient way, which helps for BI, business intelligence. It's another domain which dominates a val. So which helpful for all those business. So every day you are taking a selfie photo, selfie video, then just you are placing it in a WhatsApp status. After placing the photo or video, you can view number of view, number of bus. But the business intelligent people, they are using object recognition and tracking technology. Please see the picture. For example, I am putting my Facebook status. The status was feeling sad. I am just putting my Facebook status. The status was feeling sad. Immediately there are number of likes, comments, etc., etc. That's not a problem. The picture or the content was analyzed. The picture, feeling sad picture, something. It was analyzed by the business intelligent people. Immediately they replied that each and every picture was analyzed. So immediately the business intelligent people, they replied kerchief advertisement. If feeling sad, I need kerchief, just for fun. So if my Facebook status was raining, just I'm take a raining video or raining photo and upload it on Facebook or WhatsApp status. Immediately the business intelligent people applies the augmented reality algorithm and extract the information. Now there is a raining on that particular location. So immediately they sent a umbrella or raincoat advertisement. On that location. Immediately they represent umbrella or raincoat advertisement. That's called as business intelligence. That process which will be called as business intelligence. So immediately you can extract the WhatsApp status and Facebook status and sends the business advertisement. That's called as augmented reality. So augmented reality which also helpful to business intelligence. Next, digital marketing. The digital marketing is another dominating technology. The digital marketing is another one of the dominating technology. For example, I'm giving a very small example. All are more familiar about the term called as Zomato, Swiggy or Uber Eats. The companies are challenging very soon. Within 2 or 3 years, they are replace all the kitchens. Everyone orders food via Uber Eats, Swiggy or Zomato. I'm giving you one of the small example. It's also recognize the things. It also analyze the data. For example, one fine day I'm opening a Swiggy app, then I'm ordering vada. Actually, the cost of vada was 10 rupees, but immediately they place advertisement via my thinking. That is vada. It's one of the object. It's similar like donuts. So they are immediately offering donut is available. It's a bun material, something with a sweet. Then the cost was 400 rupees. Actually, I'm planning to order for 10 rupees, but immediately they place advertisement as well as something called as Virat Kohli or some favorite person. They says donut is a secret of my energy. So the intelligence was applied and then I'm ordering for 400 rupees. That's also recognition of matching of object. Vada and donuts are similar. So tempting the human behavior and ordering via Swiggy, Uber Eats, otherwise Zomato. Current trend was changed. Every object was recognized. Each and every. For example, Google. Everyone having Google account. I think 100%, not 99.9%. 100% everyone having Google account. Every mobile is connected with Gmail. So each and every activity, each and every behavior was analyzed. So actually, a quote says, Google know yourself better than you know yourself. Google know yourself better than you know yourself. So that's the thing. So at last, I'm entering into the excellent technology of dominating technology of the society. It's a dominating technology of the current society that will be called as haptic technology, which helps with the help of augmented reality domain. So haptic technology, there are 3 haptic technology. Yeah, everyone ordering dresses via online, but still there is a crowd in RMKV, Pothys or Chennai sales. What's the reason behind that? There is a Flipkart, eBay, Amazon, numerous number of shopping carts are available, but you are purchasing items via the shopping cart, but still you are entering into the shop like Chennai Silks or RMKV or Pothys. What's the reason behind that? So there is a research gap. There is a research gap is available. What's the research gap? The research analysis is very, very needed, very, very important. So the reason behind that is touch and feel. So if you are entering into RMKV or Pothys, you can directly touch and feel the environment. You can directly touch and feel the environment. But in the online market, you cannot touch and feel realize the materials. So now the mobile screen, everyone having mobile phone. So in the top of mobile phone, all of them pasting a screen card. A new screen card was arised. It was pasted in the top of your mobile phone. You can touch and feel the environment. The real exposure was provided. So augments the real exposure, real textures of that picture, of that photo, of that dress was provided via touch and feel. Touch and feel is one of the excellent technology in haptic. Touch and feel is the first and foremost technology. So very soon, which dominates the world, touch and feel technology. Then next one, smell and feel. Additional device which connected to your mobile phone, which will provide the sense smell. So smell and feel is another excellent technology which connected in haptic technology. Smell and feel is another one of the excellent technology which is connected in your mobile phone. So smell and feel is one of the excellent haptic technology. Then next one. Now it's a real augmented reality. You are entering into real augmented reality domain. If you are entering into hotel, and just take a photo of food items, and via your mobile screen, just taste and feel. The same taste and feel exposure which provided. So you can already extracted those information and augments it into your mobile phone. So the mobile, in the top of your mobile phone, you can paste a screen card. The screen card which made up of octopus cells. Octopus is a fish. So it's made up of the octopus cell. So with the help of that, you can taste and feel the same exposure which was provided. So for example, if you are entering into hotel, just take a photo of nearby person food item. Entering into hotel, just take a photo of nearby person food item, and you can taste and feel a mobile screen card. Just taste your mobile screen, the food item, that is Italy, Pongal or Buri, the same taste and feel exposure which provided in the screen card. That's augments your real environment. That augments the real environment. So haptic technology is a technology for touch and feel, smell and feel, and taste and feel, which dominates the world. It's one of the excellent augmented reality domain. Very soon, which will be available in the market. There are numerous research opportunities are available in the domain. So utilize that opportunity for your funded projects or any other research works. So augmented reality is one of the excellent domain. So object recognition, tracking, as well as detection, which helps you for this business intelligence, digital marketing, as well as haptic technology too. So some of the other applications, digital watch, touch and feel, sense and feel, then several set of online games, same exposure, that augments exposure, which will be provided, virtual exposure, which will be provided, hologram. It's helpful for education. It's helpful for education in an excellent way. The touch and feel environment was provided in an efficient way, which also helpful for shopping market. The next generation overview of augmented reality with the help of MATLAB software, computer vision toolbox to achieve object detection, tracking, and recognition. It's my small overview. I'm started with a very small story. The story was where to put your effort. The moral of the story was where to put your effort. So the IFET College of Engineering in Electronics and Communication Engineering Department, they are organizing, they are choosing such an excellent topic, that is applications of augmented reality and virtual reality using MATLAB. So utilize the 14 days opportunity to learn new things. I'm starts with the story. So at last I'm ended with the story. The story was hare and tortoise. Hare and tortoise. All are more familiar about the story. So once upon a time, there was a race between hare and tortoise. The reason for the race was who runs faster. Hare said, I am a fast runner. Tortoise said, no, I am a fast runner. So there is a race between hare and tortoise. Who runs faster? So race was starts. Hare ran faster than tortoise. Tortoise was slowly moved. Then there is a huge distance between hare and tortoise. So hare takes rest under a tree. Tortoise will slowly move and reach the destination. Now what's the moral behind the story? The moral behind the story, all are more familiar about the moral. The moral behind the story was slow and steady wins the race. Slow and steady wins the race. Did you accept the moral? Yeah, 1.5 hour session, I will explain MATLAB and object detection, object tracking, and numerous applications as well as haptic technology. So slow and steady wins the race. It's not possible. So I'm giving a very small example. In my UG Computer Science and Engineering, first semester, the subject which will be named as Fundamentals of Computing and Programming. I am slowly studied that subject and complete the subject in my 8th sum with S grade, that is 100 marks. Did you accept that? First sum fail, second sum fail, third sum fail. But 8th sum I studied the subject well as I complete in S grade, 100 marks. Did you accept that? So slow and steady wins the race. It will not accept. So story continues. So because of laziness of hare, it lost the race. So hare think about its failure, then analyze the reason for failure. Analyze again. So because of its laziness, it lost the race. So next day, hare met tortoise again, then arrange for another race. Now the race was starts. Hare ran faster than tortoise and reached the destination in a very short duration. Now what's the moral behind that story? Dear friends, fast and consistent, which will always beat slow and steady. Fast and consistent, which will always beat slow and steady. So always be fast, be active, then only you will achieve a love. Then anyway, now tortoise will lose the race. So next day, story continues. Next day, tortoise will think about its failure, then analyze the reason for failure. Analyze again. It's impossible for winning a hare in the same strategy. So tortoise choose a different strategy. In between source and destination, there is a river. So now tortoise met hare again, then arrange for another race in a different route. So hare accepts. Now the race was starts. Hare runs faster than tortoise, but in front of the river, hare was stopped. Tortoise will slowly move and swam on the river and reach the destination. Now, dear friends, what's the moral behind the story? The moral behind the story was choose your core competent area. Choose your battlefield. After that, you can play on that field, you will succeed. If you are interested in augmented reality, you can choose augmented reality as your core and play on that domain. If you are interested in virtual reality, choose virtual reality on your domain and play on that field. So choose your core competent area and then you can play on that field. Surely you will succeed. Tortoise choose his core competent area, that is a water, then play on that field, it will succeed. So choose your core competence and you will succeed. Anyway, hare will lose the race. So the final race, the story continues. The final race. Now hare and tortoise are good friends, then arrange for a final race in the same path. In the ground, hare will took over tortoise on the top and run faster. In the water, tortoise will took over hare on the top and swam faster. Again in the ground, hare will to cover tortoise on top and run faster. Now both of them reach the destination in a very, very short duration and a fast manner. Now, what's the moral behind the story? The moral behind the story was teamwork. Unity is strength. One of them learning at least what is augmented reality of that session. Another one learning what is object detection. Another one learning what is object tracking or object recognition. Another one learning how to implement via CV toolbox or object detection. Another one learning what is complement, something like that. If you work as a team, then only it's possible for achieving, providing a real research work to the society. So needs teamwork and unity is strength. So always it need teamwork. So at last I conclude my session in my mother tongue Tamil. புயலும் வெல்லும் ஆமையும் வெல்லும் முயலாமை ஒருபோதும் வெல்லாது. If you work hard, then only it's possible for achieving or learning augmented reality. So always it needs hard work. So if you, and now 1.5 hour session you are learning object detection and object tracking, then you can put your effort on trying the same on MATLAB. Then only it's possible for achieving everything. Unity is strength. Anyway, your hard work is needed, your smart work is needed for achieve everything.